went to Home Depot, we went to Amazon.com, and we got ourselves a pressure reader, and now we can record pressure as the volume changes. So you already saw the lab where we just attached the vacuum pump to this, and you saw the volume of the air increase as the pressure decreased, but we didn't know what the pressure was. So now we're gonna get some real data. The thing to be aware of though is that this is at 0. So this gauge pressure is relative to atmospheric pressure. So we're gonna have to go back once we get the data, and we're gonna have to add the 1 atmosphere of pressure back into our data.
It's time to goggle up.
All right, we're ready. I've been anticipating this all day. Let's see what it does.
Okay, you say the pressure and I'll say the volume.
20.
It was 70 when you said that. Okay, turn the pump off for a minute.
It's gonna come back now.
Okay, now when it's going slowly in reverse, let's try and look. Okay, let's figure out when it's right at 20. There's 20. Can we see where the volume was? It was about 70. Let's figure out. There's right at a half a kilopascal, and we're at 40. Watch. There's at 10 psi, and we're at 1030. All right, I think we got some good data points.
So let's go with the pressure readings that you see in the picture. And the pressure readings were in inches of mercury. So I don't want inches of mercury, so I had to convert to kilopascals. And then not only did I have to convert to kilopascals, but then I had to subtract that value from 101 kilopascals, which is 1 atmosphere, minus the reading. So I have 3 pressure readings. So here are my pressure readings. My pressure readings were -11 inches of mercury, which turns out to be -37 kilopascals, and 101 minus 37 is 64 kilopascals. So this is the reading, this number here is the reading that we're gonna use for pressure. Then my next number, at this pressure, I had a volume, so we're going to add in a volume here of 30 mils. So my volume is in mils, okay? This is my actual kilopascals. Okay, so then at 40 mils, my inches of mercury was -15. My actual kilopascals, according to the gauge, would then be -51. 101 minus 51 is 50. So this is the pressure reading we're going to use. Then at 50 mils, my inches of mercury was -17. This converts to -58 kilopascals. 101 minus 58 gives us 43. This again is the pressure we're going to use. Then at 60 mils volume, my inches of mercury was -19, which converts to -64, which 101 minus 64 gives me 37. Again, that's the pressure I'm going to use. And lastly, I had 70 mils of air in my graduated cylinder inside the vacuum pump, and the pressure reading in inches of mercury was -21. Converting to kilopascals, that's -71. but we were at 101 kilopascals in the room, so 101 minus 71 is 30. So now I have two columns of data, and these are the two columns of data that I'm interested in. The volume that was in the graduated cylinder combined with the actual pressure that was on the water or on the graduated cylinder or inside the bell jar of the vacuum pump. Now, yesterday I taught you that P1V1 should equal P2V2 should equal P3V3 should equal P4V4. What does that mean? That means if I take pressure and I multiply it times volume, I should get a constant, and in science we often call our constant K. So in this one, if I say 64 times 30, I get a constant of 1920. Now, if this is halfway good, my next constant should be very similar to that. So 50 times 40, I get 2000. That's not bad considering I have a leaking vacuum pump. My seal was leaking and my fittings were leaking. Okay, so let's keep going. That's actually pretty good. 43 times 50, 2150. I'm going up. I shouldn't be going up. I should be staying constant. Let's try the next one. 37 times 60. That's not bad. It's still going up a bit. And then 30 times 70. Okay, good. Thank you for not going up anymore. Now, these data are all pretty close to a constant number. Given the fact that my vacuum pump was leaking at the seal and the connections were leaking slightly, the data is actually pretty good. So what we're going to do in a moment is we're going to take the data and we're going to plot it. So here we have the data written out in with the gauge pressure, the actual pressure, measured volume that we saw, and the predicted volume, and then we even have our error. You can see down here that as I get closer to high pressure, my error term gets very large. And that's because at that point, the fact that my vacuum pump was leaking at the seal and at the all the connections, it really started to affect there. So what we did when we graphed the data is we went ahead and we considered right here where we had our best data. Now, the measured volume is what we actually got. How did we get our predicted volume? Right here. How did we get this predicted number? All we said was that P1 V1 equals P2 V2, and then we solved for the V2 each time. So you can see that we have pretty good tight data given the fact that our vacuum pump was leaking at the seal. I need to get a better base. Okay? Typically when you plot Boyle's law, you plot pressure on the y-axis and volume on the x-axis. The blue data is the predicted volume, so that's the perfect data, and the orange dots are the measured actual data, the experimental data. You can see that we got this beautiful Boyle's law curve even though our data wasn't perfect. This curve illustrates the inverse relationship between pressure and volume. So despite our difficulties, I'm very pleased with our outcome, very pleased with our results, and I didn't expect to get such a pretty graph.